Hi, welcome back again. And following up on where we were in the last section talking about water clocks, let's lead into a subject matter that is a favorite one of mine, sword making. Sword making is a combination of an art and a science. And there have been great civilizations that have grown up, become successful because of the fact that they were able to make better weapons. Swords back in the 14th century, 15th century were the weapon of choice before the guns were invented. But sword making is actually an art in many ways. It's not something that can be mastered that easily, especially if you want to get the high quality, high strength, and high toughness. Invariably, those are the two properties that don't go hand in hand. So what I want to talk about a little bit is Damascus swords. Damascus swords have a very interesting microstructure. They're very, very high strength. They maintain sharp edges, but at the same time, they have high toughness. So when you take a Damascus sword and strike an object, it doesn't break easily, but at the same time, it is very sharp, so you can slice through something. The question is, how does that happen? Damascus swords are made of steel, and steel that has different layers of carbon content. You have layers with low carbon and high carbon. Now, when carbon is present in steel, what carbon does is it reacts with iron to form a carbide, iron carbide. So when you have layers of high carbon and low carbon, you have regions that have high content of iron carbide, which is a very hard material and prevents blunting of steel. And surrounding it is softer material, which is primarily iron with very low amounts of carbon. That is the one region that absorbs all the impact. So this microstructure that you see here, those little squiggly lines that you see there, the darker regions are high carbon, the lighter regions are low carbon. And if you look at that microstructure, that's a beautiful microstructure. It's very, very difficult to develop in a lab today. So the question is, how did they do this in the old days? The way they did Damascus swords was by heating raw iron in the presence of green leaves and wood chips. If you think of green leaves and wood chips, they're all carbonaceous material. So you're trying to find a way to infuse carbon into the steel so they would create a fire, and then they would throw these green leaves and wood chips in there so that when they decompose, they gave you carbon, fresh carbon, and then you would stick your steel blade into it and the carbon would diffuse in. Then they would hammer it back, and then they would do the process over and over again. And it was an art. That was the art part. So there was a swordsmith who knew how to do it just right. One of the interesting asides of it is a recent study has shown that some of the carbon that is there in these Damascus swords are actually carbon nanotubes. Carbon nanotubes are a relatively new discovery, and people have gotten Nobel Prizes for this in the last 20 years for the discovery of carbon nanotubes. And it's quite possible that the people in antiquity were actually using carbon nanotubes to make their Damascus swords. They just didn't know about it. The next thing I want to talk about very briefly is microstructure of steel. For the moment, don't worry about this iron-carbon diagram, but what I want to try to emphasize to you, this diagram shows on the x-axis carbon content, on the y-axis it shows you temperature, and the different color-coded regions tell you the regions of stability of different structures. But what I would try to bring your attention to is if you heat a steel up to very high temperature, let's say 900 or 1000 degrees C, it goes into a phase called austenite, which is a single phase. All the carbon dissolves in the structure. And then depending on how you cool the steel and how much carbon you have there, you have the power of generating any microstructure you want. So it is a very powerful way in which you are able to control the properties of the steel by controlling the way you heat treat it. So when you're working with steels, heat treating the steel is actually a very critical aspect of it. So leading up to the next type of sword, the samurai swords in Japan, they're also very, very beautiful swords, very nicely developed. And again, the same basic concept that the Damascus swords had, which is being able to develop steel with alternate layers of high carbon and low carbon. The samurai swords were done a little differently. They would take two sheets of steel, one sheet of steel that had high carbon, one sheet of steel that had low carbon, bring them together, heat them up, and when they were hot, they would hammer them, spread them out, and fold them, hammer them again. So you're actually building this up layer by layer by layer. And so you would have one layer which was high carbon, one layer of low carbon. And once all of the layers were all structured, you may have 1,000 layers, which means it takes a long time to make a sword. You have to fold it over and over and over again. And then once you finish the folding and you make those multiple layers, then you do the finishing. That was where the artistry came in to the samurai sword making, where an expert engraver would engrave the sword with specific patterns and designs. But the strength and toughness of the samurai swords came from the fact that you had alternating layers of high carbon steel and low carbon steel, which gave you both a combination of high strength and high toughness. I'm not sure people back then knew that exactly that was the reason for it, but now with advanced techniques, we're actually able to make a better understanding of the exact reason why these swords had such high strength and toughness in them.